this session, we're going to be walking through Module 1, which contains Traditionalized Finance, DeFi, Decentralized Finance, and CeFi, Centralized Finance. Next, we're going to be talking about DeFi primitives and the common topics you're going to run through or need to learn whenever you're diving into decentralized finance topics. Then we're going to walk through oracles. And then lastly, we're going to finish off with common ERC standards. In this first module, we're going to be touching on TradFi, which again is traditional finance, CeFi, centralized finance, and DeFi, that's decentralized finance. Okay, let's talk about TradFi, traditional finance. When we think about TradFi, we're thinking about conventional institutions such as banks, insurance companies, and brokerages. So think stocks, think your bank account. These are the typical traditionalized finance topics we're going to be discussing. And that's also just what TradFi is. Whenever you hear this in the crypto space, some people may think to themselves, what is TradFi? This is exactly what we're talking about. The pros of traditionalized finance is regulation, things like FDIC, and then also just the longevity of this space. In some cases, regulation can be bad, but I want to talk about the good pros of regulation. While we won't get on the topic of innovation, we're going to talk about the protection for investors. The reason why things are regulated is so that it protects investors from shady businesses, malicious practices within running a business. Think of Enron. Think of these scandals that has happened in our traditional finance history that has put a mark on this industry. And so these are regulation are just ways to ensure or prevent these negative things from happening. When we talk about things like FDIC, so if you have an American bank account, it's likely that it's FDIC insured. So that means if the bank were to go under, you'd be insured up to, I believe it's $250,000 to $300,000. I can't remember the exact number, but this means that you are insured your money, at least a limit of your money, if something bad were to happen. And then also just longevity. Traditionalized finance has been around for a fairly long time. These practices have also been around, so these are things that have been time tested and have a pro in that regards. Now the cons is that in the traditional American financial system, you need a lot of capital to access specialized markets. So what I mean by that is specific funds that you may want to put your money into, you may not be allowed to enter into these funds unless you have, a minimum of, let's say, $1 million in assets or cash. These are just things that are unfortunate to people who don't have the kind of money to invest in these type of mechanisms, but that is just the case of traditionalized finance, at least in the American sense. Now of course, there are different investing mechanisms around the world, and we're not going to really talk too much to those, but from what at least we out of SolidityATL know most about is our financial system. So that's pretty much a con. And in terms of regulation, so another con, or I know we talked about the pro regulation, but a con of regulation is that it can sometimes, and in often cases, it can stifle or shorten the innovative potential that a DApp or application, sorry, not DApp, but that an application or a business can have. Okay, CeFi, centralized finance, talks more to centralized exchanges like Coinbase and Binance. These are organizations or corporations that are not necessarily full-time traditional finance and not necessarily full-time decentralized finance. So what that means is a company like Coinbase, for instance, they allow you to buy and sell crypto, but what they don't do is allow you to necessarily keep your crypto. When you purchase Bitcoin on Coinbase, that money stays on Coinbase. They have access to your private keys, right? Now, they are providing extra security, and that is a pro in a sense, because you're not having to worry about the security of your secret recovery phrase or your private keys. This is all managed by Coinbase. But on the negative side, as a con, these are not your keys, which means it's not your coin. If something were to happen at Coinbase and someone were to get access to your private keys, you essentially would lose all your money. And this is something that centralized finance has. This is a problem with centralized finance. Now, again, it's a pro to have security managers at Coinbase or Finance or Binance, and the reason for that is it's a pro for people who are new in the space. If you are not familiar with crypto, you're not familiar with how to manage your crypto, it's best that, for the time being, as you're learning, you allow another corporation, at least a trusted corporation, to handle this. Many people will definitely disagree with this, but this is just an opinion that I have taken on the security side of crypto, is that when you first get in, it's okay if Coinbase or Binance is managing it. Now, the point after 3, 4, 5 months of you being exposed to crypto and interacting with things on chain, you should be at the point where you can manage your own keys. But hey, that's just I guess an opinion. So we'd love to hear what y'all's thoughts are. Feel free to leave comments in the video if you have any other thoughts on that. Now, another pro is that it's an on-ramp to crypto, so it's typically very hard to jump into crypto without a centralized finance type of exchange being set up. It's local Bitcoins is not really much of a thing anymore. It's very tough to go to like your bank and ask for some crypto or use your banking systems to exchange your money for crypto. The places you can do this is usually Coinbase and Binance. Now, there are other on-ramps coming on board. MetaMask is bringing up a way to on-ramp users. Other wallets are starting to bring more ways to on-ramp their users. But in terms of centralized finance, it's Coinbase, Binance, and these are the people who are known for being an on-ramp to crypto. Okay, decentralized finance. Decentralized finance is essentially fully on-chain. These are smart contracts and users managing and interacting with their crypto. When we think about decentralized finance, we can talk about companies like MetaMask, Uniswap, Aave. These are fully managed and handled on chain, at least from the standpoint of your keys, your cryptocurrency. Where is this being stored? Who has control of it? Uniswap, MetaMask, Aave, when you store your crypto on those exchanges, they don't necessarily have custody of your cryptocurrency. You do. Now, they're smart contracts. We're not going to go too deep into this just yet, but smart contracts are handling the money. So we could say, it's a third party that's handling your cash, but at the end of the day, it's not a human. It's not a person who can choose to, let's say, steal your money or slide some extra money underneath the table to siphon these users' funds out of this, account or this infrastructure, this application. So what's a pro of decentralized finance? And that is self-custody. That means you own your crypto. You manage everything. No one else has the ability to control your assets unless they have your private keys or some other thing like your secret recovery phrase to access your crypto. Next is, like I was saying, smart contracts are handling your crypto, your assets. Smart contracts are code that's on chain that pretty much facilitates the interactions that your crypto is making with various protocols and various other addresses or smart contract addresses. A con is that there's rugging and scamming. you're going to have a lot of businesses that spin up, and I would put businesses in air quotes if you could see me. These are organizations that act like they're a legitimate business. They get users to invest in them, and they absolutely disappear. This is kind of touching on the regulation piece. In the traditional finance world, this can definitely allow someone to be brought to justice by arresting them or the organization. But in the crypto space, we have a lot of freedom, so this just opens up room for a lot of rugging, a lot of scamming. You have different hacks, which is a con because there are not people managing your money, and this code can have bugs, and that is an unfortunate case where your code has bugs, it's managing someone's money, and now there's an individual who figures out this bug and steals everyone else's cryptocurrency. And then lastly, there's lack of insurance mechanisms. These are definitely getting better in the DeFi space, but we unfortunately don't have it's not like a very common thing for everyone to have some form of insurance or something like FDIC, where if you missed out due to a rug or a scam or whatever it was, something led to you losing your crypto, it's not very common to say, hey, this is insured by some regulatory framework or whatever it is. Like I said, there are different insurance protocols out there, and you can do your own research to investigate those. But at the moment, there isn't a very common standard that everyone uses from this insurance standpoint. In this next module, we're going to run through DeFi primitives. We're going to talk about decentralized exchanges a little bit more, lending and borrowing, things like AMMs, staking. We're going to talk about some governance and DAOs, and then touch on a little bit about MEV, or minor extractable value, maximum extractable value. Okay, so starting off, we have decentralized exchanges. We talked a little bit about this, but remember, it's a peer-to-peer marketplace where transactions occur directly between crypto traders. It's typically managed by a smart contract, as we can see right here. Let's hide that for a second. As we said, financial transactions that aren't officiated by banks or brokers or payment processors or any other kind of intermediary. This is made between smart contracts and other people. Now, an important thing to note here is that liquidity correlates directly with the amount of tokens locked in a liquidity pool or within an exchange. Liquidity is very important when we talk about decentralized exchanges, because essentially there needs to be people on the other end who's willing to accept or take the order. Now, this is specifically talking about the order book method. Let's say, I want to make or trade 5 ETH for 10 wrapped Bitcoin. I'm making this order. There needs to be someone on the other end who's willing to take it, who's willing to say, okay, we have the liquidity to give you this 10 wrapped Bitcoin for your 5 Ether, right? So if you have no liquidity, if there is no one willing to pay you your wrapped Bitcoin for however much ETH you have, this can be an issue. You have, lack of liquidity, and this can really change how a pool operates. If you have no liquidity, you're not going to be able to make these orders. That is an inherent issue with, the order book method. This is kind of taking from the traditional finance space. This is how, a lot of orders are fulfilled, but this is just for the base level of a decentralized exchange. Next, we're going to talk a little bit about AMMs, and we'll jump into that later. Okay, so we're going to talk more about automated market makers. This is what you will hear in the crypto space as an AMM. They are permissionless and automatic way to trade by using liquidity pools rather than a traditional order book method. So to talk a little bit more about this without getting too deep, is they use something called the constant product formula. That's X times Y equals K, which essentially it's a method or algorithm that allows you to self-balance your liquidity pools. So as a quick example, if let's say we're going to first need some liquidity providers, we need people who are going to deposit or stake some tokens with the idea that they're going to make some type of yield off of staking these tokens. And then let's say there's another user on the other end who wants to, again, swap 5 ETH for 10 RAT BTC. Essentially, this constant product formula is going to allow this pool to self-balance. So depending on how much there is of one token, there's always going to be a constant product K. This is going to always need to stay the same. So if I have a pool with 1,000 rat Bitcoins and only a few ETH, as you can imagine, this pool for the ETH will be worth more, right? Because I have a ton of rat Bitcoin, but a very small amount of ETH. And on the other end, if I have a ton of ETH and only a little bit of rat Bitcoin, you can imagine, because that's scarce, and we have to keep this constant product formula the same, this rat Bitcoin is going to be worth a lot in this pool. So that's just a little taste of how automated market makers work. You're not necessarily filling in orders. You have people who deposit liquidity into this market, and then this constant product formula is used to make sure that constant is staying the same. So just jumping back into this, you can provide continuous liquidity for a wide range of tokens, and some examples of this are what Uniswap v2 or what Uniswap uses. They use this method. They are an example of an AMM. Okay, so now we're going to talk a little bit about perpetual swaps. These are essentially a type of derivative that allows traders to speculate on the price of an asset with long and short positions. So essentially what this means is an investor can place bids on a speculated price. So if I believe the price of Bitcoin is going to be, I don't know, let's say $40,000 within the next 2 weeks, I can place a bid on this type of order, and depending on the direction that this trade goes, I can be on the winning side or the losing side. Now, the interesting thing about perpetual swaps is that they allow traders to open up leverage positions. So leverage is the means to place a bid or an order with money that you don't even have. So someone can place an order with 10x leverage, which means they're able to place an order with 10 times the price of that asset, and they may not even actually have the means to fulfill this order. Now, what happens is a protocol will have some type of liquidation ratio, where if a user passes a threshold where the liquidation ratio reaches a certain point, all of their assets within that position will be liquidated, and the protocol will essentially take away that money and keep it for themselves. This can differ depending on which protocol you're interacting with, and what happens to that money can differ, but that's essentially how a perpetual swap works. An example, if you want to look at a current dApp that does this, is DYDX. They offer perpetual swaps. And also, as an aside, if you're familiar with futures trading, this is very similar to perpetual swaps. So we're going to talk about lending and borrowing. I know we touched on things like AMMs, which has some form of lending and borrowing. Liquidity providers are essentially the lenders, and the borrowers are the people who come in and swap in and out of the AMM. But we have other forms of lending and borrowing. So an example could be MakerDAO. So at MakerDAO, you're able to offer crypto loans with a trustless approach. It's only managed by smart contracts. Borrowers can lock their crypto assets trustlessly as collateral, and then lenders earn interest by providing liquidity. So at MakerDAO, if you wanted to be loaned, if you needed a loan, what you would do is you would lock up your ETH, and you would be provided with stablecoin DAI. And in order to receive your ETH back, you're going to have to pay off this loan back to MakerDAO as well as an additional fee. You have to pay off an additional fee to reclaim your ETH. So the decentralized space allows a lot of interesting mechanisms for lending and borrowing, and MakerDAO is a great example of this use case. We're going to talk a bit about staking. Staking is when you lock crypto assets into a smart contract and in exchange for rewards, and it generates some type of passive income. Also, a big important part of this is that you still retain ownership of that collateral or asset. So when you stake your tokens, you may stake some token into Protocol X, just an example. Essentially what happens is you are able to achieve some type of incentive from this. So if you stake your token into Protocol X, you may receive a yield of, let's say, 4%. So this is a great way to incentivize users to interact with the token, interact with the protocol, if they're able to essentially gain some money off of that token or that staking asset. So another important thing is that typically to allow a user to have governance tokens, you implement some type of staking mechanism. So if I stake token X into my protocol, I also give them a governance token. So that pretty much shows that this user has invested in my platform, so I should give them some ability to make decisions on where this platform should go in the future, what kind of things should be implemented, what kind of features should be added. We'll talk a little bit about DAOs and touch more on this topic, but this is a really big important part of staking. In summary, it allows you to create incentivization. It allows you to incentivize your users to use a specific token or asset, and at the same time, it can be a great way of tracking who's interacting and who's using your protocol. All right, so we're going to talk more about governance in DAOs. This is going to follow up from our staking conversation. So, when we talk about governance on chain, we're talking about managing the governance and the decision making for a dApp or protocol. And the people or organizations who implement this are termed DAOs. These are called decentralized autonomous organizations. This just means that there is no one party or one centralized authority that rules the decision-making process for the protocol or whichever ecosystem we're talking about here. So the decision-making process and voting process is automated. This means that there is some type of architecture that involves smart contracts and voting with governance tokens. So in the last slide, we talked about staking, and when you stake your tokens, you will typically receive some form of a governance token. Well, what this governance token allows you to do is to make decisions on the future of this protocol or exchange or dApp or whatever it is that this DAO is implemented on. So smart contracts are set up to perform these org activities. So like I said, when you have, let's say you have two governance tokens and there is a proposal that's pushed out, the proposal may, for example, have something that says, we want to increase the yield of our native token by 3%. And users can vote yes or no. And depending on the winning vote, the smart contract will be able to implement this update automatically, right? And the biggest thing about this is that these are transparent. The rules that are made are all on chain. You can see the conversations that's happening in real time, and you can also see the historical record of what happened. And you can also see the smart contract code that's executing these new decisions. All right, so we're going to finish off this module with MEV. This is coin miner extractable value, also maximum extractable value. So the definition of MEV is that maximum value can be extracted from block production and access of the standard block reward and gas fees by including, excluding, and changing the order of transactions in a block. Now, the important thing to understand about MEV is that essentially how it works is these miners or these users who have access to the mempool, they have first look access at what transactions are being submitted on chain. And just follow along here. I'm trying to break down how this works under the hood. So going back to this example, these miners, these individuals have access to the mempool. They can see these transactions that are being submitted well before other people, other users, right? Now, of course, other miners are getting these things at the same time. They're getting this information at the same time. Regular users who are just, sending, receiving transactions and trading their crypto, they're not really looking at having this kind of access. Now, these users who have access to this mempool before everyone else, they can see what transactions you and I are submitting. And they can also run simulations to see how profitable that transaction could be. So let's say I go to trade, to make a huge trade, a miner or someone who's engaging in MEV activities, they can see my transaction on the mempool and see that I'm about to perform some type of operation that makes me, let's say, $1 million. Well, what this MEV bot or this user can do is front run my transaction, which means they see the mempool, they see my transaction in the mempool, they copy it, and they submit that same exact transaction with a higher gas price, which allows their transaction to hit to be operated on, or it allows their transaction to run before my transaction, thus giving them the $1 million instead of myself. So this is how MEV looks under the hood. A few cases or a few examples this could look like is DEX arbitrage. So let's say there's a token that's worth $5 on one chain and $4 on the other. Obviously, the smart play is to buy this token worth $4 and then make a profit of $1 on each of those trades. At the exchange, it's worth $5. So that's what arbitrage is. There's liquidations on DeFi protocols. These miners, these MEV bots can be the ones performing these liquidations to make profits. There's sandwich attacks, which we'll get into as we talk a little bit more about DeFi vulnerabilities and DeFi attacks. And then there's long tail MEV, which is essentially unique and interesting ways to perform arbitrage on chain, whether that's, for example, front running NFT transactions and and figuring out ways to gain value or extract value on those types of trades.
The next DeFi primitive we're going to cover are oracles. We're going to go through what an oracle network is and the importance they play in blockchain technologies. Oracles are one of the most important DeFi primitives, not only for developers, but oracle manipulations are also one of the top DeFi exploits for security. So oracles are a very keen concept, both for developers and security researchers. Oracles are a hybrid system that acts as a bridge between on-chain smart contracts and off-chain infrastructure. You can have data that's stored in a database like Postgres, or that's available from some web API. And in order to get that data into a smart contract, you have to use an oracle. And an oracle acts as a two-way bridge. So you can move data both from off-chain sources on-chain and vice versa. One of the most common use cases for oracles is prices on-chain prices. So to determine the price of an asset, whether you're using some DeFi protocol, that price is determined by an oracle, meaning that that data is coming from off chain somewhere. As a developer, if you need to build not only DeFi apps, but any dApp where you have a smart contract that needs data off chain, the oracle pattern is what you're going to want to use. An oracle is a hybrid smart contract system, meaning that there's some on-chain smart contract component and there's some off-chain component as well, where some trusted party takes that off-chain data and puts it on-chain through a smart contract. There's a spectrum of centralization and decentralization around oracles, just like there is in most aspects of protocols in Web3, where a centralized oracle is a single entity will be able to control that data feed of that data coming on chain, meaning that say you're looking for the price of a given token and there's only a single source putting the price feed on chain. If that source lies or has an outage or is it get affects the system in any way, then that is a single point of failure. There are some protocols that do maintain their own oracles, so that's always something to be on the lookout for during a security review. And as a protocol developer, having a centralized oracle is a single point of failure. So just being aware of the risk when doing that. Some of the pros, so it's easier to update. There's no consensus or less consensus than there would be in a more decentralized network. There's less latency between updates because there's less consensus. And in a trusted system, it's easier to fix. But the cons heavily, like in my opinion, heavily outweigh the pros, where you have to trust that oracle inside of your system because they're a single point of failure, both from if they become malicious or if they have an outage, they're just a single point of failure. One resource that I would recommend to read further on oracles is this website here. Outside of Oracle pattern, they have what I think a very good write-up of many blockchain design patterns, and they break down the pattern very well into trust, cost, and just all the details you could want to know about Oracle pattern. But I really like this image to show what an Oracle is doing. So you can see there's some off-chain components. It could be a database, could be a backend server. This Oracle usually is a combination of some type of node and some type of smart contract. And so that data will come into that Oracle, and that Oracle will post that data on chain. Decentralized oracles are on the opposite end of the spectrum as centralized oracles, in that data feeds are provided from multiple sources. So there is not a single point of failure and more tolerance for the oracle system to function from malicious actors or bad nodes going out. The most commonly used and the top industry decentralized oracle network is Chainlinks. And others that I've seen in audits are StormJ. This one is attempting to bring a little higher or less latency to their price feeds, so more high frequency trading on chain. And UMA I've also seen as well. Some of the trade-offs that come with using decentralized oracles are it does take it's longer for the network to get to a consensus on a price feed. So you can imagine if you had 30 nodes telling you the price of a certain token, that network has to reach consensus on the price before it actually gets published on chain. There's also the risk that comes when protocols are integrating with these oracles where there's implementation bugs that are exploitable. And we'll get to some of those in later sessions. And the last one there is correctly configuring a fallback oracle in case of the network outage. That also is true in the case of centralized oracles, but given that a lot of protocols use decentralized oracles, mostly Chainlink, understanding what fallback options are is also very important. One other aspect of these decentralized oracles that's important is they usually have mechanisms to punish malicious data providers. And one common way to do that is with the concept of slashing. So a lot of these decentralized oracle networks implement a proof of stake consensus algorithm, and malicious nodes can be slashed. This image you see here, I took from Chainlink's website. So I encourage you to go on their website if you're interested to learn more about their Oracle network. I've used their docs extensively, both as a developer and during audits. So this is an illustration showing what their Oracle network does. You can see there's external data, could be some internal systems, traditional finance payment systems. They also have products that can help you set up your own Oracle network for whatever use case you have. And they act as a bridge to bring that data on chain. And developers can interface with their or integrate with their contracts to actually read that data on chain. And they are on multiple networks. So this is a good illustration of what the Oracle pattern looks like and what Oracle networks are doing. As I mentioned, Chainlink is the industry standard for decentralized oracles. If you're ever on a DeFi protocol and you see the price of a token, there's a high likelihood that Chainlink is that data provider for that price. I want to take a look at a couple of their products. So the first one is their data feed. And so this Oracle network product is specifically for getting price feeds on chain. And you can see that there's different price feeds for different assets on different blockchain networks. So if you're on a given DeFi protocol and you see the price of Ethereum in USD, there's a high likelihood that this is the data feed that price is coming from. You can see inside this data feed the nodes that are inside of this network. You can see the amount of stake that is locked in this network using the Chainlink's link token. And you can also see what networks this data feed is supported on. The other Chainlink product I wanted to go over is their Chainlink functions. This is still in beta, but I think it's a very great use case of oracles, because instead of just supporting price feeds, Chainlink functions will support any data source. So you can think of it, a simplified way to think of it is a Lambda function that you get to execute on a Chainlink node to bring data on chain. One key concept in a lot of community driven programming languages is the notion of native standards. In the case of Java, those are JSRs. In the case of JavaScript, it's ECMAScript or ECMA standards. In the case of Ethereum, they are ERC standards. In this module, we're going to talk about what is an ERC, and then go through some of the most commonly used ERC standards, except for the last one there. That one is not super commonly used, but it's growing in adoption, and I think it's an important one to cover. These are also some of the first standards I will introduce to new auditors, because these are some of the ERC 20 and ERC 721 are the most commonly used standards you'll see in a security review. I'm going to approach this first from as an engineer during this slide and this session here, and later on in the course we will deep dive into the security aspect of ERC 20 and ERC 721. This is meant to purely be an introduction. What is an ERC? ERC stands for Ethereum Request for Comment. ERCs are used for proposing and standardizing new tokens and smart contract standards on Ethereum. You may have also heard of EIP, which stands for Ethereum Improvement Proposal, which covers a wider range of topics. I'm pretty sure every ERC also has an EIP, but the other way is not true, because Ethereum Improvement Proposals can also include updates to the Ethereum virtual machine or to the different Ethereum node client software or to Ethereum's governance. It's generally wider than the ERC standards. And with both of these, even though these standards are well used and there's a lot of protocols that implement them correctly, not all implementations of these standards follow the spec 100%. So if you ever see a contract that is implementing a standard, it's always important to check if that standard is actually being correctly implemented. The first ERC's token standard we're going to cover is ERC 20. This introduces the concept of fungible tokens, meaning in a given ERC 20 implementation, so for a given token, every token of that type is the exact same. So some of the ERC 20 tokens that you see here are USDC, which is here, and Chainlink, Link as well. You can't distinguish one USDC token from another. They're exactly the same. Most token launches use the ERC 20 standard, and I want to walk through some of the key functionality. I encourage you, as I've done earlier in this course, to go on ethereum.org to read their documentation. They also link directly to the original EIP if you want to see the original source. There's also some history on the standard, the motivation behind it, things like that. But what I want to focus on are the interface that is defined by the standard. Every ERC and EIP standard, or every ERC standard it comes as an interface. Not implemented, but it's presented and documented as an interface. So what we're looking at here are the methods and the events associated with the ERC 20 standard. The four methods that I really want to cover are the transfer function. So this is the method that gets called whenever any address wants to transfer a token to another address. This is the method that every ERC20 token has to implement in order to make that happen. There is the transfer from method, which is the second method that I want to go through is the approve. So this is the method that gets called. Say you have 100 USDC and you would like to give permission to a contract to be able to transfer some of your tokens on your behalf. There's a lot of different DeFi applications for that and non-DeFi applications as well. The three methods that allow for the transfer of your tokens by someone else is first the approve. So this is the method that it gets called to give another address permission to spend a certain amount of your ERC or transfer a certain amount of your ERC. The second method that is involved with someone transferring your tokens on your behalf is transfer from. So this method is called when someone else wants to transfer tokens on your behalf. And usually in implementations, this transfer from only allows the approved amount to be transferred. And the last method I want to cover, which is also the third method in transferring on your behalf, is allowance. And this is the method that is a read method to view what allowance an address has to be able to transfer your funds. All these other methods are important, but I just wanted to cover those because from a security perspective, that's where a lot of vulnerabilities are, and this need to require a lot of attention wherever you see these. As I mentioned a few minutes ago, ERCs are just interfaces. There's just a definition. It's up to protocols to actually implement these. So I want to share a couple of the most popular implementations that protocols use to make it a lot easier and secure to launch ERC20 tokens. The most popular implementation is implemented by OpenZeppelin. This is also an open source implementation, so you can go on GitHub to see that code as well. Their docs deep dive into what their specific implementation allows, and they also have some additional functionality if needed. The second implementation that I want to recommend is Soulmate. So Soulmate, similar to OpenZeppelin, has a smart contract library that implements different standards, but also helpful utilities. And they also have an implementation of the ERC20 standard. These are the two implementations that I have seen in any audit that I've seen with the ERC20 token. It's one of these two. Usually there are people who implement it themselves, and in those cases, generally just be more aware, because the OpenZeppelin implementation and the Soulmate implementation have been heavily audited, and they've been existing for a few years, so they're battle tested. So if someone's implementing this on their own, that's just something to pay extra attention to make sure there's no issues there. The next token standard we're going to go through is the second most popular, the ERC 721, which is the non-fungible token. For a given ERC 721 implementation, each token is unique and can also have data associated stored on that token. Again, I would like to refer to the ethereum.org documentation. I think it's concise and does a good high-level overview of the standard. Also gives some historical context. You'll see that some of the methods on ERC 721 are similar to ERC 20, such as the transfer from, the balance of, approve. The methods that I want to go through first are transfer from and approve. Those are similar to what we mentioned before for the ERC 20 standard, where in this case, instead of just having a from address and a to address, there's now a token ID. So this token ID is unique for every given NFT or ERC 721 token. And so that's what gives it its uniqueness. Every operation that you perform on an NFT, you have to provide the associated ID. So when transferring, it's the from address, the to address, and also the token that you want to transfer. Same thing for token approval. The next method that I want to talk about is, you notice there's a transfer from, but you also notice that there's safe transfer from, which is, there's two different implementations of it depending on if you want to pass call data as well. We're not going to worry about that, but just know that the safe transfer from method is recommended over the transfer from method for a few different reasons. One of them being that the safe transfer from method checks that an address is capable of receiving an NFT. There's some situations where if you use the transfer from address, an NFT can get stuck because not all addresses can receive NFTs. Another difference is in the safe transfer from. If you're familiar with the notion of callbacks in other languages or frameworks from Web2, such as React.js has callbacks where you're reacting to things happening. JavaScript has callbacks. The callback pattern exists in other programming languages. In the case of ERC 721, whenever there's a safe transfer from, there's a possible callback that can be had from the to address. So whenever they actually receive that NFT, if it's a smart contract, they can then execute some code. So those are some of the differences between transfer from and safe transfer from. And it is recommended to use safe transfer from. I encourage you to take some time to go through these standards. We're going to come back to this later once we start diving into vulnerabilities and exploits. The two implementations, again, that I want to cover come from OpenZeppelin. What I'm showing here is your documentation breaking down their implementation and some of the additional features they built on top of it. So if you look here, you can see all the different methods they implemented. One thing I do want to note is in the actual token standard, there is no mentioning of minting or burning, and that is not included in the specification. So if you look here, there's no mentioning of minting or burning. And that's one of the most common things associated with NFTs. So it's up to protocols to implement that minting and burning functionality. That is not a part of the standard. So in the OpenZeppelin implementation, they provided that for protocols to use out of the box, so they don't have to worry about building it themselves. And you can also go on GitHub to see all the source code from this if you wanted to take a look. The other implementation is from Soulmate, as I mentioned before, and you can also go on GitHub and look through their implementation as well. It's always highly recommended to use these implementations. I have seen some people implement this on their own, but generally it's safest to use one of those two implementations. What I'm showing here on this slide are just some of the popular NFT projects that have come up in the past 5 to 6 years. So CryptoKitties was the first NFT launch NFT project that really went viral back in 2017. If you're familiar with the Ethereum name service, the actual subdomains. So if you ever see a address with a .eth, the implementation of that involves an NFT for ownership of that subdomain. And the last one here is the POAP, or proof of attendance. This is a project that allows anyone to create free NFTs that show proof of attendance. I've gotten them at conferences and different events, and it's just a nice way to get community engagement and prove that someone was at an event. The last ERC standard I want to cover is the ERC 4626 tokenized vault standard. This ERC is not super common, but it's growing in popularity, and I've seen it on multiple audits, and I've also worked with it as a developer. This ERC is meant to be a standard way for implementing a vault. And you can think of a vault in the sense of like a bank vault or an asset vault. In this case, it goes to be a permissionless way for a smart contract to store and manage crypto assets. In this specific case, those assets will be in a single ERC20 token. As with the last standards, I recommend going to ethereum.org's documentation directly to get better understanding or high-level understanding. Is the key assets or the key methods I want to go through here are first the asset. Every ERC20, when it's actually deployed, because ERC20 tokens are smart contracts that are deployed, as with ERC 721 and this standard as well. When an ERC20 token is deployed, it has an address. And for this vault standard, this asset method simply returns the address of the underlying token. There's also methods for getting the total number of assets, the notion of shares, and converting from shares to the ERC20 token and back. This is essentially the converting from the depositing asset to here are the shares proving you deposited these assets. The key methods that I want to go through are the deposit method. So this is where the message sender will deposit a certain number of assets, and the shares representing that deposit will be sent to the receiver. There is also a mint method, which does something very similar. For withdrawals, there's a withdrawal method which burns the shares from the owner, and it burns this number of shares from the owner and sends the token asset to this receiver. And aside from withdraw, there is also a redeem method that does something similar. As with the last two token standards, both OpenZeppelin and Soulmate have implementations. So this is a really easy way to get started with staking contracts, protocols that involve staking with rewards, also escrows. Those are the type of use cases for this ERC. So here OpenZeppelin has some documentation on it, and they also have an API. And here you can see Soulmate's implementation as well. Every vault that I've seen so far has been one of these two. I'm sure there's someone who has built it on their own, but generally OpenZeppelin and Soulmate's implementations are the two. The last thing I want to show for ERC 4626 is a Doom dashboard I found that is very helpful, keeps track of contracts deployed using that standard. And you can see here, started looking back in 2021. As time goes on, there's more and more contract deployments implementing the standard.